having some function, we usually check if it has an output which is equal to 0 for certain input. These values of arguments where function become equal to 0 are called zeros of the function. The zeros determine where the graph of the function intersects the x-axis, which usually gives us more information about shape of its graph. In general, certain function may have any number of zeros. As present examples, we see the cases of single zero and the case of non-zero. Other interesting point at the function graph are intersection with y-axis. From the function definition, we can expect that certain function may have only single or non-y intersection. We say that a function is increasing on some interval I if for each pairs of values of its argument, while the function with great argument is greater. Similarly, we say that a function is decreasing on some interval I if for each pairs of values of its arguments, values of function with great argument is minor. As an example, function f is decreasing for the positive semi-axis and increasing for the negative one. In general, the character of dependency may change several times. As the example, function is increasing on the interval x minor than x1 and x greater than x2, and decreasing between x1 and x2. Another useful property which may have a function is symmetry. There are two important cases of symmetry which we discuss here. That a function has the following property: values of the function corresponding to the opposite values of arguments are equal. In this case, we say that a considered function is even. An even function are symmetric about the y-axis. Another case arises from rotating a graph by pi angle about the origin. If new graph will look exactly the same, we call that a function is symmetric about the origin. Formally, this property says that the values of function with opposite values of arguments are opposite. Such function, called odd, and odd function are symmetric about the origin. There is one particular example of symmetric function which called absolute value function. This function is defined as follows. If values of its argument x is negative, it returns minus x, and if x is positive, it is on x itself. It is easy to see that absolute value function is even, and therefore symmetric about y-axis.